Congress to NOAA to develop for the climate data records the same kind of thing that you have for weather records. Now, you have to appreciate the amount of data that are coming back from the satellites that we have up there. It's enormous. One satellite alone, which was the first one to go up, Terra, in its earlier days, was sending back 1 terabyte of data per day. And the idea is to have a record where you start with the information that's processed at a level that can be used by the person, the user, scientist, whatever, that can be traced all the way back to the instrument, what I refer to as the photon to electron problem, with all of the uncertainties and so forth in there, to try to get a handle on this. This is a very important issue, and it's going to be, I think, some significant contributions to this area as well as to climate change research in general. So I want to encourage you to go to that if you have a chance. You can see something that's being born and has the legs for longevity even in this environment, that is economic environment. I'd like to preface the opening remarks or Jessica's presentation by saying that the atmosphere is different than land or water. Land you can partition, and over the years we have partitioned land and then fought wars over it. You can sort of constrain or control or try to control the flow of water. You can't do that with the atmosphere. It is the most egalitarian of the three. It visits everybody. So, sorry, John, but you may live and breathe in Fairview, but it doesn't matter. The fact is that what happens in other places on the globe can impact you and vice versa. So, for example, China uses high sulfur coal in their coal-fired plants, which they're putting online at a massive rate per week. The sulfur dioxide from those coal-fired plants is showing up on the coast of California. We don't use high sulfur coal anymore because many years ago, you may recall, that there was an outcry in the northeast of the U.S. and the southeast of Canada about acid rain and deforestation. That was because of high sulfur coal. We now use low sulfur coal. But with a population 4 times ours and the number of coal-fired plants that they have, they're having a major impact on the climate. Same thing's true with Africa, though a different situation. The dust from the Sahara Desert blows across and comes over the east coast of the U.S., adds to the particulates, and what is of concern, at least to some health experts, is the possibility of viruses traveling on the dust, so that you get infectious agents that you may not be developed an immunity to yet. If you look at maps, you can see where effluent from the east coast of the U.S. is flowing over toward Europe and Africa and the Mediterranean. So we're not decoupled. I can't fence off the atmosphere. I can't make it flow in a direction that I want to. And it doesn't necessarily help, by the way, going higher, because a lot of this stuff is well mixed in the atmosphere, permeates everything. So we're going to start with sort of a global and national view, and then focus in on western North Carolina, Franklin County, and Asheville. And I hope you'll take away from this a sense of urgency, not that it's a futile problem. There is a standing joke around NASA headquarters that earth sciences is referred to as the science of dread. That is what we're going to tell you. You may not want to hear, but then on the other hand, if you went and paid a doctor for a doctor's visit and some tests, and the doctor finds out that you have a real problem, do you not want to know? You can't take corrective measures if you don't know what the problem is, so we have to define it, we have to really identify it, and we have to get the data to make good decisions. So with that as a backdrop, I'll turn it over to our first speaker. And if you want to use, I brought a green as opposed to red, not because it's Green Mondays, but because your eye is more tuned to the green than it is to the red. So it's easier to see this than it is to see the red. And if you'd like to use
I don't know if I can do two things.
Well, as long as you don't aim that and click for the slide and aim this that way, you're
I'll try with the red. If you can't see it, then I'll switch to the green. Thank you. As John said, in this talk that I'm going to give, we're going to sort of look at a global focus and bring it down into our area in Asheville. And this is a table that shows important gases and particles in our atmosphere, and they can basically be separated into two broad categories. Those that reside for long amounts of time in the atmosphere and those that reside for short amounts of time. The long-lived gases are what we refer to, of course, as greenhouse gases, and they typically stay in the atmosphere from anywhere to about a decade to well over 100 years. And all of these gases have a warming effect on the climate. There are also short-lived gases and particles, and the difference being that rather than residing in the atmosphere for a long amount of time, they are only in the air for about a week to maybe a week or two, or about a day to a week or two. So they tend to have more regional and local effects than long-term gases do. And the other difference is that not all of the short-lived gases warm the atmosphere. Many of them cool as well. And so we'll take a look at that. But we're going to start off by looking at the effects of the long-lived gases. We know that the world is warming, and we know that human activities have very likely contributed to this warming in the last 50 years. Since the beginning of the last century, the global average temperature has increased by about 1.5 degrees Fahrenheit. Observations and climate models have indicated to us that greenhouse gases are indeed responsible for this increase in the global temperature. So this isn't really a question at this point. And this graph does a very good job of illustrating the link between the changes in temperature and carbon dioxide. This is from the time period around 1880 till today. And the black line shows the increase in carbon dioxide level, and the blue and red lines show the global average temperature with respect to the 20th century average. So when it's blue, it's cooler than that average, and red is higher. So we see an increasing temperature over time that sort of parallels the carbon dioxide concentration.